Hello and welcome to a screencast on air masses and fronts. We're going to start today with air masses that you can see here on this map, and air masses are defined by their temperature and humidity. For instance, we have a continental polar air mass here that usually moves in from Canada into the United States. As it moves down, the global winds or jet streams pick it up and move it quickly north and east. Now, the air mass that moves in from Canada, because the air mass forms over dry land and in a cold region, it's continental polar, which means that it's relatively dry and it's also relatively cool. We also have our tropical air masses. You can tell the tropical air masses form closer to the equator, because that's a region of where warm air would form. And here we have a maritime tropical. This means that it formed over warm water. This air mass would be relatively moist and warm. There are other air masses that influence the United States, like continental tropical and maritime polar, but we usually refer to continental polar and maritime tropical because these are the air masses that most influence the weather in New York State. On weather maps, we typically see the boundaries of air masses indicated by a front symbol. So if we had a cold air mass, it would have a cold front symbol to represent the front of that air mass. Or if we have a warm air mass, it would be represented by a warm frontal boundary. For the most part, most air masses move across the United States from west to east. This is because we have the jet streams and the global winds called the southwest winds or the prevailing westerlies that push the air masses from west to east. So you can see here the United States falls between 30 degrees north and 60 degrees north. So therefore air masses moving across the United States would be pushed by these southwest winds to the north and east. The jet streams also push air masses. So if you had a continental polar air mass that moved in from Canada, the jet streams would push it to the north and east, and the southwest winds would also push it to the north and east. In this screencast, we're going to focus on a cold front. Typically on a weather map, this is the way a cold front will look, okay, which means that this is the frontal boundary of a cold air mass. So if this is the frontal boundary of the cold air mass, behind it would be the cold air. Ahead of it, we have warm air. This, again, is a map symbol that we're using, and it's also the above view. So let's look at the above view, which is up here. I have the frontal boundary symbol right here on the above view. We can see that we have a cold front, so behind it we have the cold air. Now the triangles on the cold front always point in the direction that the cold front is moving. So for instance, right here on this map, here we have the cold front, here are the triangles. We can see that that cold front, that cold air mass, is moving towards the east. In this diagram here, we have the same setup where we have a cold front that looks like it's moving east. We have the cold temperatures behind it. Ahead of it, we have the warmer air. Below, in this diagram, we have the side view, or the profile view of what the cold front is actually doing. So here's the above view, or a map view, and here's the side view. So the cold air is running into a warmer air mass. Here we can see we have the warm air mass, and here's the cold air mass that is moving forward. You can see that we have this steep incline here to represent the cold air mass, the cold front. This is because cold air moves very quickly in onto the warm air. This causes the warm air to then rise up very quickly, causing thick, heavy clouds and precipitation to usually form along a cold front. Before we get into that, let's label our areas here. We know we have warm air. Now typically for New York, when we reference the warm air, we're looking at a maritime tropical air mass. This is warm, moist air. The cold front, behind the cold front rather, we have cool, dry air, and I have the wrong symbol there. We're saying cool, dry. This is, yeah. Let me fix that. Okay, I'm going to try that again. Here we have cool, dry air behind the cold front. So here's our cold front, and behind the cold front is our cool, dry air. And that cool, dry air is running into warm, moist air. Because warm, moist air is less dense than cool, dry air, when the cold, dry air runs into the warm, moist air, it's going to cause that air to rise, cool, condense, and precipitate. Okay, so let's define what the weather's like before a cold front passes. You can see we have Batman here. Batman is in the maritime tropical air mass. This tells me, other than the bells ringing, that Batman is experiencing warm, moist conditions, that the air pressure is relatively low because it's warm, moist conditions, okay, and that the relative humidity is probably kind of high. So, then we have Ninja Lady over here. Ninja Lady is experiencing cool, dry conditions because, well, she's in a continental polar air mass, and the relative humidity is low, and the air pressure is high. Now, trouble's coming for Batman because the cold front is coming, and at the frontal boundary, you have warm, moist air that's rising, cooling, condensing, and precipitating. Typically, we get heavy precipitation, and that's what's moving towards Batman. After the front passes Batman, after he experiences heavy, brief precipitation, he will then experience the same conditions that the ninja person is experiencing, which is high pressure, nice weather, low relative humidity. He will also be located in a continental polar air mass. And because the conditions are so nice, they definitely will not fight. As a matter of fact, they're going to be very happy. This is, on this map, we're going to take a look at the above view here. Here we have the cold front, and we have a city located, let's say, right here. And we have a city located right here. So the cold air mass is moving towards the east. So this city, city A, will experience heavy precipitation as the cold front moves in, followed by clearing conditions and high pressure. This city here has already experienced the cold front and heavy precipitation and is now experiencing high pressure, cool air, low relative humidity. I hope this helps you understand cold fronts, and I will see you tomorrow.